Hi everyone, we are group number one of Columbia University's Big Data Analytics course in fall 2022, and welcome to see our presentation video. I am Ruobing, and this project is finished together with my teammates Huang Lijie and Yufan. Our project is credit card overdue analysis and data visualization. We choose this topic because it is hard for us international students to get approved for a credit card. And we are looking into the related factors through this project. There are three main goals of our project. The first one is visualization, as we use the various charts to provide users with a straightforward relationship between the credit card overdue status and the applicant's personal status. The second goal is classification and prediction. Two MILP classifiers were trained to classify the applicant's overdue status and overdue time span. Then a 2D sigmoid activation function will merge the output of both classifiers and produce a final possibility for getting a credit card. And then the third goal is web page deployment. Flask is not only a popular web framework, but it can also easily integrate machine learning models and other useful Python tools, enabling us to provide fast response predictions back to users on a web page. Overall, the novelty of our project lies in the combination between visualization and prediction of credit card overdue on a single and easy interactive online platform. So now let's talk about the dataset we have been used. For the raw data we use is an existing dataset from Kaggle that stores more than 400,000 distinct credit card records. The whole dataset is stored into CSV files. In the first file, each applicant has one ID and 17 features that may influence their credit status. In the second file, we have the overdue status and the overdue time span for each single applicant ID. And with respect to the Big Data 3Vs, our raw dataset contains a large number of distinct records, which is good enough for the volume and the variety. And for velocity, there is actually a huge difference in the amount of credit card applications per day, depending on bank sizes and services. Hence, our analysis did not shed light on the actual velocity of credit card applications right now. And further and continue, let's talk about our data preprocessing. We have multiple history transactions under every applicant ID, so we need to calculate the overdue frequency and the average overdue time span for each applicant by reducing. And then to ensure the variety and the correctness of the result, we clean the dataset and make sure all the applicant IDs are unique. Then for the final step is to link the applicant status and the overdue status by applicant ID. And as for the classification purposes, we still have one more thing to do, including label, construction, min-max normalization, and one-hot encoding. After the preprocessing, we have 58 feature columns and 2 label columns. So move forward, let's talk about the methods we have been used. We use the Spark Data Frames API to organize the processed dataset and then apply various charts to visualize our data using PyE-charts. And for the data preprocessing, we mainly use Pandas, NumPy, and the SQL Server Management Studio. And as for the machine learning part, a total of 2 MILP classifiers are constructed and evaluated using TensorFlow. Skitlearn is also used to provide matrices like the correlation matrix and the confusion matrix. Finally, Flask is chosen as a web framework, and Bootstrap UI is used to decorate web pages and provide users with a variety of interactive functions. So as for the results, here I show you some results about the machine learning classifiers. On the left-hand side, this is a correlation matrix of the preprocessed feature columns. And the right-hand side shows the structure of our MLP classifier. So finally, let's talk about the system layout. Before we deploy on the cloud, three Google Cloud services are used. Firstly, the computing and visualizing tasks are executed by PySpark. They are performed on a Dataproc instance with three servers. After visualization results are generated, they are stored in the cloud storage as HTML files. Lastly, the Flask project is deployed on a cloud computing instance and provides a web application to users across the internet. And here, the attached video is a quick demo of our application. So you can see we used various charts to visualize all the related features for each single applicant. And you can see here we basically categorize all the features into the 6 feature groups. And now comes to the prediction part. So here is basically select random values for each required values to make the prediction. And once you click submit, you will see a possibility calculated and displayed on the web page. So I will also show you another particular case which shows an extreme prediction result. So I already have our application right here, and I already named the required values you can see here for making a prediction. And you can see once we submit the inputs, a pretty low possibility is calculated and displayed. So this is all of our project presentation. Thank you for your watching.